In day 6 of chapter 12 here, we'll actually be connecting the circles we've been studying in geometry to circles in algebra. And we're going to do that by doing a couple of different things. One, we're going to be graphing these circles in the coordinate plane, and we'll review a little bit about graphing here. And then the second thing we're going to do is write the equations of circles. So to begin with, let's review what it means to plot points and to write their coordinates. Remember, coordinates have to be ordered pairs. And in ordered pairs, the x has to come first, the y has to come second. They have to be in parentheses, and they have to be separated by a comma. All of those things have to be there to be ordered pair coordinates. So for the point A, you can see that it has moved left 5, and then it's moved down 1. If it's moved left 5, that's a -5 in the x, and down 1 is -1 in the y. So the ordered pair for A would be -5, -1. Now for the B has gone to the right 6, and then it has gone down 5. So if you go right 6, that's a +6, and then you go down 5, that's a -5. So the ordered pair for B would be 6, -5. For the next one, C is right 2 and up 3. If you go right 2 and up 3, the ordered pair would be 2, 3. And the last one I've asked you for the coordinates for is the D. And for D, we've gone left 1 and up 2. So the ordered pair would be -1 and 2. And again, you must have the parentheses, and you must put them in the order with the x first, then a comma, and then the y. When they ask you to plot a point, it means you're going to go to that location, and that location would be right 4 and down 3. And you're going to put a dot there and then label it with the letter E in this case. So if I go right 4 and then down 3, that will put me right here. And then I put the letter E next to it. That's what it means to plot that point. Okay, enough review about plotting points and ordered pairs. Let's get on to circles. Recall that a circle is the set of all points that are equidistant from a fixed point. Now, for a circle, if that fixed point happens to be the origin is the point 0, 0. Well, then the equation is much simpler. It's just x squared plus y squared is equal to the radius squared. So if you look at this first circle right here, the center is at the origin. And then we can see that the radius is equal to 3. Since the center is at the origin, we know it's going to be x squared plus y squared equals r squared. The left side is always x squared plus y squared if the center is at the origin. And since the radius is 3, we would have to take 3 squared to get our 9 on the right side of the equation. This is the equation for that circle. Let's go ahead and try one. So this is one of those problems where the center is at the origin. So it's going to be of the form x squared plus y squared equals r squared. We look at the graph to determine what the radius is. The radius is 6. If the radius is 6, then r squared would be 6 squared. So our equation would be x squared plus y squared equals, and then 36 on this side. And that's how you write the equation of a circle with the center at the origin. Let's try another one of these, centered at the origin. So this one does not give us a graph, but it says that it's equation of a circle with the center at the origin, and they tell us the radius is 8. Since it's centered at the origin, we know it's going to follow this form. X squared plus y squared equals r squared. R was given to be 8, so r squared would be 8 squared. R squared then is 64, so our equation, x squared plus y squared equals 64. Now let's try one where we pick out the center and the radius and sketch the graph. You can see by looking at this one that it is centered at the origin. Because it fits the pattern, x squared plus y squared equals r squared. So the center is just going to be 0, 0. The r squared is 4. So if we take the square root of both sides, we find out that the radius is actually 2. We're going to go ahead and sketch this graph. Center's at 0, 0. Radius is 2, so I move out 2 in each direction. The easiest way is to go right 2, up 2, left 2, and down 2. And then we sketch the circle. Now the circle does not have to be perfect, but it does have to go through those points. And we're done. Let's try a few more examples. So in these problems, we're just asked to look at the equation and to pick out the center and the radius. Well, when the center is not at the origin, when it's not at the origin, then it has this form for the equation. You'll notice that this is the opposite of what we see in the equation. So for example, on number 10, we see an x minus 3. So, sorry about that. So that means for our center, we're going to use a positive 3. And similarly, for our y, we see a y minus 1. So for our center, we use positive 1. It's the opposite of the equation. Now for the radius, we have r squared must be equal to 100. So when we take the square root, we get 10. Let's try a couple more of these. For number 11, we want the opposite of what's with the x, so we'd have negative 6. The opposite of what's with the y, so we'd have positive 2. And for our radius, we have to take the square root of 225. That comes out to be 15. Now the next one sometimes can be a little bit tricky for students. There's nothing with the x. So in our center, that means we're going to have a 0 there. And then the opposite of what's with the y would be negative 4. And then for the radius, we need the square root of 12. Well, this one we'd have to break down 4 times 3. 4 breaks down into 2 times 2. Since we have 2 2's, we can take out a 2. One of the things you'll be required to be able to do is to pick out the center and the radius when you're given the equation. Let's try one where we have to pick out the center and the radius and sketch the graph. Let's do the center first. The opposite of what's with the x would be negative 1. The opposite of what's with the y would be positive 2. So I know that the center is left 1 and up 2. So there's my center. The radius, I know that r squared is equal to 9. So if I take the square root, r is 3. So my radius is 3. That means I'll be counting 3 to the right, 3 up, 3 to the left, and 3 down. And then we'll go ahead and sketch that graph. And again, these do not have to be perfect circles, but we want them to go through those critical points. Here's one where we're doing the reverse of what we see. of what we just did. In this case, we're given the graph. We're asked to pick out the center and radius and to write the equation. Now, the center is really just a matter of getting the ordered pair for this point right here. It looks like we have gone left 2 and down 2. So my center is going to be at -2, -2. For the radius, we'll just count how much we went directly to the right, or to the left. In this case, I'll count to the left. So it appears to me that we've went 1, 2, 3, 4. So the radius here is 4. Since the center is not at the origin, I have to follow the pattern, x minus h squared plus y minus k squared equals r squared. If I fill in the -2 and the -2, recall that in the equation it's the opposite, so I would have x plus 2, and then I would have y plus 2, and then I also need the radius squared, and if I take 4 squared I get 16, so 16 goes here. My equation, therefore, is x plus 2 quantity squared plus y plus 2 quantity squared equals 16. Let's try a few more of these. Each time you do these problems where you write the equation, it has to begin with finding or locating the center. The center on this one is right here. So that center would be at 3, 1. Next, we have to find the radius. The radius here appears to be 3. Since the center is not at the origin, we follow the pattern x minus h squared plus y minus k squared equals our r squared. And recall, we must use the opposite. So it's going to be x minus 3 squared plus y minus 1 squared. And then also recall we need to square the radius. 3 squared works out to be 9, so 9 goes over here. That means the equation for our circle, x minus 3 squared plus y minus 1 squared equals 9. Okay, let's try another. This one we're doing the reverse of that. This one we're going to pick out the center and the radius, and then we're going to sketch the graph. We, of course, need the center first. For the center, we have to use the opposites. The opposite of what's with the x is 1. There's nothing with the y, so it's 0. So there's our center. The radius, well, r squared is 16. So if I take the square root of both sides, I find out that the radius is 4. Sketching our circle, I'm going to go right 1 and up 0. And now I need to move 4 in each direction. 1, 2, 3, 4 to the right. 1, 2, 3, 4 up. 1, 2, 3, 4 to the left. 1, 2, 3, 4 down. And then we do our best to draw a circle that goes through them, keeping in mind that it does not have to be a perfect circle. It just needs to look like a circle and go through those points. Here they ask us to write the equation, and they give us the center and the radius. For our equation on the top one, we need to use the opposite of the x coordinate, and we need to use the opposite of the y coordinate, and then we have to square the radius. The next problem, same exact directions. We have to use the opposite of what's with the x. And then the y is 0, so there'll be nothing with the y. And then we have to, well, they gave us the diameter. So if the diameter is 40, the radius is going to be 40 divided by 2, so the radius is 20. And we really need the radius squared. Now, number 19, They ask us again for the equation, but they don't give us the center or the radius. The first step has to be to find the center. And we're going to reach way back to the beginning of geometry, and we're going to use the midpoint formula. The midpoint formula was x1 plus x2 over 2, y1 plus y2 over 2. So for our particular problem, we have to take 2 plus negative 4 over 2, and then we have to take 6 plus negative 2 over 2. So our midpoint comes out to be negative 1 and 2. That's our center, negative 1, 2. Next, we need to find the radius. Now, the radius can be found by using either the Pythagorean theorem or the distance formula. This time I'm going to use the distance formula. And I have to go from the center, negative 1, 2, to one of the endpoints. I'm going to go to 2, 6. So the distance would be the square root of x2 minus x1 squared plus y2 minus y1 squared. And I would have 2 minus a minus 1 squared plus 6 minus 2 squared. 2 minus a minus 1 is really 3 squared. 6 minus 2 is really 4 squared. So that distance comes out to be the square root of 25. So that distance is 5. And that's our radius. The equation of our circle then is going to be x plus 1 squared. We have to use the opposite. And then y minus 2 squared. And then we need the radius squared, which would be 25. You always have to know the center and the radius first before you can do anything else. This one, they've asked us to identify the center and the radius. We always need the center first. The center, negative 2, positive 3. Recall it's the opposite of what you see in your equation. Left 2 and up 3. There's my center. The radius. Well, I know that r squared is 25, so my radius is 5. Now to sketch the graph, I will go right 5. 1, 2, 3, 4, 5. Oops. 5 from the radius, or from the center rather. And then up 5. 1, 2, 3, 4, 5. Left 5. 1, 2, 3, 4, 5. And finally down 5. 1, 2, 3, 4, 5. And we go ahead and we try to sketch our circle. Doesn't have to be perfect, but we want it to look somewhat like a circle, and we do want it to go through those points. Couple more. Okay. Now this one tells us the center, 2, negative 3, over 2, and down 1, 2, 3. So there's my center. And then they give us a point that's on the circle, 2, down 1. Now we have the center, but we need the radius. Now I think we can get the radius here by just counting. The radius appears to be 2. So the radius is 2. We can go ahead and sketch the graph then. So we go 2 to the right, 2 down, 2 to the left. We already have the one that's 2 up. This is our circle right here. our equation, x minus 2 squared plus y plus 3 squared equals 2 squared, which is 4. You always need the center and radius to write the equation. One last example. This one looks very similar to the one we just did. They gave us the center again. Center's at -1, +2. And then they gave us a point that it goes through, -4, -2. Now the problem is we can't count to get that. We have to first find the radius. So the center is at -1, 2. To find the radius, we have to use either the Pythagorean theorem or the distance formula. On a previous problem, we already used the distance formula, so I'm going to use the Pythagorean theorem here. Well, when I look at my graph, I can see that it appears that I went down 1, 2, 3, 4, and then I went over 3. So in the Pythagorean theorem, c squared would equal 3 squared plus 4 squared. Now we've seen this before. I know that c is 5, so my radius is 5. I can go ahead and sketch the graph. From that center, I'll go to the right 1, 2, 3, 4, 5. Then I'll go up 1, 2, 3, 4, 5. Then left 1, 2, 3, 4, 5. And then down 1, 2, 3, 4, 5. And I'll go ahead and sketch that particular circle. Again, it does not have to be perfect. We just want to go through the points that we can. For our equation, we'll have x plus 1 squared, again, the opposite of the center point, and then y minus 2 squared, and the radius squared would be 25. Okay, so that covers the last topic in this chapter. A lot of algebra in here, and that's because you're making the connection from geometry to algebra. Good luck on it. Don't forget about the help times that are available to you.